Okay, for the challenging problem, you have one square and n minus 1 hemisphere. For example, n equals 1, right? This is the case when n equals 1. N equals 2, it's just one circle and one hemisphere, right? When n is 3, it's like one circle, one hemisphere, and another hemisphere. You can see you can adjust the location of the hemisphere, right? So the total height will change. So here the height is given, right? The height is just 2. Okay, here, what is the height? The question wants you to prove that. So we want to prove that right, for case n, the maximum height is 1 plus square root of n. So for example, here we want to prove that the maximum height is 1 plus square root of 2. We want to prove that the maximum height is 1 plus square root of 3. Okay, this is what we want to prove. Okay, so with mathematical induction, you don't need to jump into the details. So first, when n is 1, right, it's just one circle. The radius is 1, right? So the maximum height is 2, right, which is 1 plus square root of 1, right? So it is true. It follows this formula. Okay, then suppose n equals k is true, right? Which means this part, the maximum height is 1 plus square root of k. Let's say this is true. Okay, this maximum height is 1 plus square root of k, and we know this part is 1, right? So this part, it should be square root of k. Okay, suppose this is true, then for n equals k plus 1. Right. So now in total, okay, let me draw this big. This is the first circle. This is the second circle. Extra, this is the last circle. Right. So now from the second circle to the top, right, for this part, in total you have k circles, right? And here, when the bottom radius is 1, the maximum circle is 1 plus square root of k, right? When this part is 1, right, this part is square root of k. Okay, let's say when this part is 1, okay, when x is 1, this is y equals square root of k, right? What if now for this part, right, now x is, let's say, r, right, let's call this part r, then the y, it should be r times square root of k, right? So r is the radius of the second circle. Right, then this part is what? This part is still 1, right? Then this part, it's 1, it's r, so it's square root of 1 minus r squared. So in total, the height is a function of r. It's 1 plus square root of 1 minus r squared plus r times square root of k. Okay. So let's copy it down here. H is 1 plus 1 minus r squared plus r times square root of k. So k is a constant. We want to get the maximum r, right? We want to find the maximum of h. So what do? We find its derivative, right? Its derivative, this part's derivative, it's right 2 square root of 1 minus r squared, right, divided by negative 2r, and plus this part's derivative is square root of k. Okay. So we want this derivative equals 0, right? We want this derivative equals 0, so we can just do the calculation. So r over square root of 1 minus r squared should equal to square root of k. We square both sides. R squared over this is k. Right. So r squared is k minus k r squared. 1 plus k r squared is k. Right. So r squared is k over 1 plus k. R is square root of k over 1 plus k. Right. When r is this, you have maximum h, right? Then what is the maximum h? Your maximum h, you just have to sub r into this equation is 1 plus square root of 1 minus z square, right? Z square plus r times square root of k. Okay, then you just have to do this part. It is 1 plus, okay, this part is 1 over 1 plus k. This part is k squared over 1 plus k, right? So this part is 1 plus 1 over square root of 1 plus k. This part is k over square root of 1 plus k. So it's 1 plus 1 plus k over square root of 1 plus k. It is 1 plus square root of 1 plus k. Right? So when n is k plus 1, right, your max h equals this thing, right? So you can do the conclusion that, right? So the max h is 1 plus square root of n plus 1. Okay. Sorry, square root of n, right? Because here is k plus, because here it's k plus 1. It's when n is k plus 1, right? So it's 1 plus square root of n. Okay.